Welcome to this explainer. Today, we're diving into a true masterpiece of historical destruction. We're talking about a machine so legendary, so utterly terrifying, that it actually earned its own name, the Warwolf. Built specifically for King Edward I of England, this wasn't just a weapon. It was, literally, the largest engine of destruction the medieval world had ever seen. So by the end of our time together, you're going to understand exactly how this mechanical Leviathan was engineered, why it was built in the first place, and the devastating physics that made it the absolute apex of medieval siege warfare. Let's get right into it. Okay, let's drop right into the incredibly tense scene that made this machine necessary to begin with. Picture this. It's July 1304. We're just outside the formidable stone walls of Stirling Castle in Scotland. King Edward has been besieging this stronghold for months. He's poured time, money, and men into taking this fortress, and frankly, he's losing his patience. He doesn't just want a simple surrender anymore. No, he wants to make a point, an undeniable, earth-shattering point. He wants to demonstrate absolute dominance over what everyone believed to be completely impenetrable stone walls. Now, I want you to put yourself in the shoes of the Scottish garrison trapped inside that castle. They're looking out over the battlements, and what they see being assembled in the distance, well, it isn't just another catapult. It's a structure so impossibly massive that historical accounts literally describe the defenders watching its construction with a mix of awe and pure terror. They knew just by looking at the sheer scale of the timber framing going up that this right here was the ultimate castle killer. To give you an idea of that insane scale, the wooden frame of the Warwolf was audibly groaning under the immense, crushing weight of its counterweight. We are talking about a giant box hoisted high into the air, packed with up to 6 tons of heavy stones and lead. 6 tons. That's the weight of a fully grown male African elephant, suspended by medieval ropes and timber, just waiting to be unleashed. So, why on earth did Edward need a 6-ton, elephant-sized counterweight in the first place? Well, because he was facing the ultimate 14th century engineering problem, the concentric castle. You see, by the 1300s, castles were no longer just, simple piles of mud and timber. Not at all. They had evolved into these highly sophisticated, perfectly engineered machines of defense. A concentric castle is basically an attacker's absolute nightmare. You've got multiple, overlapping curtain walls. You've got massive gatehouses backed by heavy iron portcullises. And worst of all, towers that are strategically placed to provide lethal enfilade fire, which basically means overlapping angles where crossfire can cut you down from multiple directions at once. If you were a soldier trying to storm a place like Stirling, you'd inevitably find yourself trapped in designated kill zones. You'd be pinned down, desperately dodging heavy rocks, arrows fired through narrow slits, and boiling water poured right on top of you from wooden hoardings above. It was an absolute meat grinder. Because of this, medieval engineers found themselves up against a wall, literally. They had to rely on what historians call the grim logic of attrition. It's a very simple but brutal equation. If your soldiers cannot possibly survive going over those formidable trap-filled fortress walls, well, your only other option is to somehow smash right through them. You've got to bring the wall down to your level. And that brings us to the mechanical breakdown of our subject. Let's look at the anatomy of the beast, so to speak, and understand the specific physics that allowed a wooden machine to shatter solid stone. How exactly did you generate enough power in the 14th century to break a concentric castle? The secret lies in a massive leap in engineering. Just contrast a basic catapult with the advanced physics of the Warwolf. A simple catapult relies on tension or torsion, twisting ropes or bending wood, to snap an arm forward. It's effective, sure, but it's severely limited in power. A massive counterweight trebuchet like the Warwolf, however, it threw all of that right out the window. It relied entirely on the unstoppable, terrifying forces of gravity and leverage. Think of the firing mechanism like a giant, incredibly lethal seesaw. On the short end, you have that 6-ton weight hoisted way up high. On the long end, a leather sling resting on the ground. So here's how it works in action. Step 1, the trigger is pulled. Step 2, gravity takes over and that massive 6-ton weight plummets. Step 3, the long throwing arm is violently whipped upward. And finally, step 4, at the absolute peak of the arc, the sling snaps open, releasing just an unbelievable amount of kinetic energy. It was enough power to skip a massive boulder across the ground like you or I might skip a pebble on a pond. Crazy, right? But here's the thing. Medieval engineers didn't just fire blindly at the thickest part of the wall. These highly skilled siege crews understood structural engineering. They repeatedly targeted the square corners of the castle's towers. Why? Well, a flat wall can absorb a lot of impact, but a square corner is a major structural weak point. By accurately chipping away at the stones on that corner with repeated, heavy strikes, they could actually compromise the foundation until the entire tower catastrophically collapsed under its own weight. Of course, you couldn't exactly order one of these machines from a catalog. Bringing the werewolf to the battlefield required summoning the monster from scratch. It was a staggering logistical nightmare. These machines were way too big to build at home and roll across the country. They had to be engineered and constructed in the field, right outside the enemy's walls, sourcing massive amounts of timber locally. To pull this off, Edward needed a highly specialized medieval strike team. The records show it took a small army of 5 master carpenters, basically the absolute top-tier engineers of their day, directing a crew of 50 dedicated laborers. This was a massive, highly coordinated construction site, operating right in the middle of an active war zone. And as you might guess, it was not a quick process. It took Edward's engineering team 3 full months just to put this massive siege engine together. Just think about the psychological warfare of that for a second. For 90 days, the Scottish defenders sat on their walls, listening to the sawing, the hammering, the shouting, watching this apocalyptic machine slowly take shape right in front of them, knowing exactly what it was meant to do to them. The sheer volume of material was just mind-boggling. Historical records suggest that even with building it on site, it still required 30 wagons just to transport the prefabricated metal components, the massive ropes, the sling materials, and the intricately carved joining pins for the werewolf. Honestly, it was a supreme flex of the medieval supply chain. And all of that effort, all of that wood, all of those men, they were all dedicated to delivering one specific payload, a massive stone projectile weighing nearly 300 pounds. I want you to imagine a boulder the weight of 2 grown men sitting in a leather sling, about to be accelerated to terrifying speeds and hurled through the air directly at your fortress. Which brings us to the devastating climax of our story. The werewolf is finally completed. The massive throwing arm is locked into place, that 300-pound stone is loaded in the sling. The Scottish garrison inside Stirling Castle, seeing this completed machine towering over the battlefield, makes a desperate decision. Before the machine can even be fired once, they try to surrender. But here is where we encounter a truly dark piece of historical irony. King Edward looked at the white flag, looked at the surrendered Scots, and he actually refused their surrender. I mean, he just spent an absolute fortune and waited 3 long months to build the ultimate toy. He sent the Scots right back inside the castle because he simply had to see exactly what the werewolf could do. The result of that test drive was staggering and totally undeniable. With a single, deafening crack, the trigger was pulled. The 6 tons of counterweight dropped. The arm whipped forward. One single 300-pound shot slammed into the fortress. And that one shot completely leveled an entire section of the supposedly unbreakable curtain wall. The sheer destructive power was beyond absolutely anything anyone on that battlefield had ever witnessed. Yet, as amazing as it was, the werewolf was really a brilliant flash right at the end of an era. It represented the absolute, unparalleled peak of a lost feudal world, where power was projected through massive, singular wooden machines. Because shortly after this, the rise of gunpowder fundamentally changed the geometry of war forever. The age of giant wooden trebuchets was cut short, rapidly replaced by the explosive power of cannons. And those towering stone castles, like Stirling, they eventually had to give way to low, thick artillery forts designed to absorb cannon fire. Still, the werewolf remains the undisputed king of medieval siege engineering. It's an incredible testament to what human ingenuity can achieve with just gravity, wood, and mathematics. But it leaves us with a pretty fascinating thought experiment. If a team of modern engineers were given today's advanced materials, carbon fiber, high tensile steel, but were restricted to using only gravity and leverage, just like Edward's carpenters, could they build a kinetic, non-explosive machine even more powerful than the werewolf? Let me know how you design it in the comments. Thanks for joining me for this explainer, and keep your curiosity sharp.